Well, hello, everyone, and welcome to our panel. We're really pleased to be here today. And thankful that UVA School of Data Science is hosting this event, and delighted that you're spending the next 45 minutes with us and having a conversation about creating resilient student experiences with heuristic-based monitoring while balancing concerns about privacy, ethics, and bias. My name is Sherry Bennett. I'm the Chief Data Scientist at DLT, a TD Cenex company. And joining me today are Elham Tabasi. She is the Chief of Staff at Nist for the Information Technology Laboratory. And she also serves as a member of the White House National Artificial Intelligence Research Resource Task Force. And also joining me are Michael Knight. He is the Chief Digital Officer at IntelliSite. I'd like to invite everybody in the audience to submit questions in the chat box. I'll be looking at those, and towards the end of the panel, about 10 minutes, we'll set time aside to handle any questions that come in. So please enter them now or throughout the discussion. I'll also be posting some literature that might be of interest to you as well. So let's start off by asking each of the panelists to tell us a little bit about your role and your organization and what you do with the organization. Elham, can we start with you, please?
Sure. Thanks, Sherry. Thanks for the invitation. Thanks for including me. Glad to be here and talk about Nist and Nist Trustworthy and Responsible AI program. So a few words about Nist. The National Institute of Standards and Technology was actually established back in 1901. Back then, through several incidents and understanding and experiences, it became apparent that the U.S. needs an agency to focus on measurement science and standards. An example that a lot is being used is that, when there was a fire in Baltimore, a lot of other firefighters and the groups from other around came to Baltimore to help, but they couldn't because there wasn't, the equipments were not standardized. So they couldn't basically plug in or hook their fire hose into the I don't know the technical term for this. So they just all stand and watch the fire because there wasn't any standard to help them to use the equipment all across the, span of 100 miles or so distance. Today, Nist has a very broad portfolio of research. We do everything from building the most accurate atomic clock to building standards for helping developing standards for robots in smart manufacturing, to understand what trustworthy responsible AI means, to provide guidance on cybersecurity and privacy, material science, and more. Nist has a long-standing tradition in cultivating trust in IT and metrology, and that is really the purpose of the Trustworthy and Responsible AI program that I will talk about it in a few minutes.
Thanks. Michael, can you tell us a little bit about your role in your company?
Sure. So Epic.io Technologies, of which IntelliSite is an artificial intelligence and IoT subsidiary, is really focused on providing solutions that enable a smarter and safer world. That is a combination of computer vision, artificial intelligence, and data, AI. It's also correlating and coalescing information coming from our physical to digital world, right? So around IoT and Internet of Things. And of course, nothing is really complete without having a whole visualization layer as part of that. So where we really focus is in public sector and helping enable smart and safe communities, intelligent traffic validation, crosswalk safety, and also doing things like enabling universities to have a smarter and safer campus. And we'll talk a little bit today about things that our heuristics-based monitoring does and how we really bring artificial intelligence from both computer vision, so optical, as well as thermal to bear and enabling that, but doing that all under a cloud native and very open platform, which of course is the key to adoption today. So I'm the CDO and I'm responsible for research, innovation, and our engineering teams.
Great, thank you. So we, in our preparation for the panel, we talked a lot about the different heuristic-based monitoring solutions that your company and others we're starting to see out in the public used in universities and other public sector spaces. For instance, for COVID tracking and tracing, you have technology that's special around thermal scanning of individuals. There's certainly a number of solutions out there around traffic monitoring and looking at attendance using computer vision type scenarios. Can you, from IntelliSite Epic.io perspective, can you talk very generally about the spectrum of solutions that heuristic-based monitoring entails? It is IoT, it's sensor data, but there's a lot of AI modeling that goes into that, which is very sophisticated and needs calibration. So if you could tell us a little bit about your solutions that you have and how you go about developing them to give everyone in the audience a little sense of what the breadth is, that'd be great.
Yeah, happy to do that. So the one thing when bringing a solution that is going to take a lot of the different information from the physical world, right? So we talked about optical views or visual things that a normal camera that you would see, right? You have a camera phone, you take pictures, you're bringing information in from the physical world and making those digital. There's things from the physical world that are in a different spectrum, right? So like infrared or heat. That's an important part of the process of understanding what certain temperature variances, and that's used in so many different use cases. One of those, of course, can be from a human side as well. And then there's the correlation of that information, as well as being able to do that in a very secure way, so that we're maintaining data security, we're respecting privacy, and those types of different elements. So if we look at from a wide lens, artificial intelligence aligned to computer vision has a notion, and that notion has to be that we can detect, classify what we're detecting, subclassify that, track that object or that thing, right, through the specific view of not only a specific camera, but other cameras related to that, and then overlay other information as part of that. Other information can be other IoT sensors that are in proximity, or even other third-party systems that really help provide context to the situation. So context is key. Artificial intelligence, whether it relates to video and data, all of that should help us drive a better context from that. Because without context, we don't have a perspective, right? So we don't have, just because I can detect an object is there, I don't know what it's doing, right? Until I have more context, tracking and aligning other data sets to that. So what is so important as we want to help students to be able to return safely to schools, to be able to have safe transportation in a university, and then how that manifests itself certainly in the broader communities. Every one of those elements and key stakeholders is important as part of that. So that's what we really focus in on. Certainly happy to double click here in just a minute around what HBM and how that really enables safe assessments and validation of temperature and information. But I'll pass it back over to you, Sherry, for some more context.
Thank you. Well, I want to make sure that we talk a little bit about when we're building these type of models, how you ensure that you were talking about context, but the bias, right? The issues around the bias and the data, and how the models are configured to make sure that they're ethical and that there is notions of privacy, especially around student information when we're talking about solutions for campus. But let's hold off on that so we can talk a little bit about what the Nist AI framework is going to be, what the progress is to date, because I think when we talk about the development of these models and the issues around bias and ethics, that the AI framework really is something that can help set some standards right around that and what it might look like. So let's, if it's all right, if you could please talk a little bit about there was the RFI that went out from Nist on the AI framework. You had an overwhelming number of responses across academia, researchers, private sector. And there was a workshop that you hosted a few weeks back where there were 3 days worth of workshops and people and panels talking about the different issues and creating the framework, the different facets, right, that need to go into it. Can you kind of give us an update on what's going on with this work and how people can get involved with it as well?
Sure, thank you. So yes, so I'll start by giving a little bit a context driver for why AI risk management framework, and then happy to talk about work that we're doing. It's a quite, I think, sort of global understanding and agreement that AI can have many benefits to improve our lives, and we just heard from some of them from Michael. But in terms of the medicine and healthcare, the promises of coming up with better treatment and cure and drugs that can help with the treatment and cure, and then take it to the transportation, take it to the agriculture. At the same time, it's also a sort of general understanding that AI systems, AI models, as Sherry said, can come with their own certain risks. And then the notion that deep learning models are brittle and they sometimes fail for the reasons that we don't understand. And it's hard to understand because some of these failures happen on the tail of the distributions. So it's sort of difficult to create the scenarios for them to happen. So in the light of all these nuances, risks, that Nist started a program on understanding what type of risks are associated with AI, data use for training AI models, risks at the time of developing models. And this also was a response to, we noticed, for many good reasons, there are many high-level value-based AI principles. Examples of some of those global ones is the one that OECD came up with, and many countries globally, including the US, has signed up to them. But they are, while all of these are really good and emphasize democratic values, human rights, human well-being, and they are written in a way that are very high-level. Things such as systems should be fair and just. And the opportunity for us at the community is to take these high-level value-based statements and operationalize them, bring them to practice. And so Nist approach has been more from a technical angle to come up with a definition or understanding of what constitutes trust and trustworthiness. So we have been working on core building blocks for trustworthy AI. And this is a good time for me to say that Nist plans and carries out its effort in a very large engagement with the whole community, in our case, industry, academia, standard development organizations, but also policymakers to understand what they need. We are non-regulatory. None of the things that we develop is for regulations. They're all for voluntary based. But our documents and the work that we do are being used by policymakers for making policy and sometimes regulations. So back to what we're doing. So we had this effort started on understanding core building blocks of the trustworthiness, and in discussions with the community, I'm going to enumerate to you what those core building blocks are. And the first and more important one is accuracy, right? You want your system to actually work, to be accurate. Beyond that, you want it to be reliable and robust. We want them to be resilient to many different attacks, so the security of the systems. The issue of the bias Sherry mentioned, we want the system to be non-discriminatory and unbiased, understood and mitigated. And we want the systems to be explainable and interpretable, and we want the systems to be safe. The next step is to one, we have a good understanding of what constitutes trust, what is trustworthiness. In other words, what's a taxonomy of risk? We need to come up with an understanding for each of these terms. So what we mean by bias and what are the touch points of the bias in different life cycle of the AI. This is really important. It is often the case that we are using the same term, meaning different things. So spending time on terminology and vocabulary is important because our audience is a very, very diverse and wide-ranging, right? We are talking about different use cases for AI here, and then within each of the use cases, we are involving and engaging different disciplines of thought, from mathematicians, computer scientists that design the systems, to software programmers and engineers that develop them, to cognitive scientists, psychologists, and sociologists that study the impact of the systems on the users. As we were doing all this work to come up with a better understanding of trustworthy AI risks, a sort of a systematic way of what they mean, to be able to develop methods, metrics, methodologies to evaluate them, to measure them quantitatively, but sometimes even qualitatively, because the metrics for quantitative analysis and measurement is not exists yet. We also got this mandate. We also get this mandate from the Congress to develop AI risk management framework. And we were given a timeline to develop that framework by January 2023. True to the nature of the work that we do and our engagement with the community, we start the process by putting a request for information out. The request for information, let me see if I can quickly share my screen. The request for information had asked for inputs around these. I don't know if you see it or not, but I'm sharing what we RFI asked for.
We can see it.
Okay, so these are the topics that we ask information around them in the request for information that went out on July 19 and closed on September 15. On the link on the bottom of the slide, you will see where you can see all of the, well, that's a link to the RFI that we put out. As Sherry said, we got a good set of responses from a very, from almost everybody. We heard from the academia, from standard organizations, from industry, from advocacy groups, and then we produce a document that was summary of the responses that were received and the themes that observed. The link below is the link to where the summary report is posted, but about the same link, or I give you the link later, is where all of the responses to the RFI is posted if you want to just look at the raw data. What you see in this page is the themes that we identified in the responses that we received. We heard from the respondent that there is a need for defining common AI terminology for communicating risk. So that was the effort for understanding the taxonomy and developing terminology and vocabulary that we were working on. We heard overwhelmingly that's important to recognize the impact of AI on society. So it's not just a technical and technology issue. We need to worry about the impact on the AI in the society, on individuals, rather than just organizations. There were discussions, and that was, one of our specific asks, how to structure this risk management framework. We don't want it to be information overload. We want to make sure that audience can go and the audience of the framework, the user of the framework, can go and find the information where they need. We heard about the governance, and we heard about the importance of metrics and measures for monitoring AI systems and methods. We did a workshop. The link I will share with you in a second. It has the a recording of the workshop that we had on October 19 to 21st. We ran it as panel discussions, and there were panels reflecting of the themes identified in the responses. So we had panel to talk about risk and framing risk. We have panels that talk about perspectives from different sectors about AI and AI risk management, AI risk management, how it's being done today. We heard discussions around what are the technical and social technical criteria for trust and trustworthy systems. We talked about what methods and metrics is existing today for measuring some of these risk factors and what needs to be developed. And we also spent time to talk about the structure of the risk management framework. Where we are with all this is that after the workshop, we have been spending hours each day on sort of a whiteboard, coming up with a draft concept paper to put out before the end of this calendar year to get input from the community moving forward. What I want to show you quickly is that those core building blocks for trustworthy AI that I talked about them. So there's another document posted on our website that provides some context background about each of them and what we mean by any of these things. But just to summarize, we have 4 technical requirements or criteria: accuracy, reliability, robustness, and security. We have another 4 social technical criteria: mitigation of bias, explainability or interpretability. Maybe we have to divide them into 2 different topics because they're different. Privacy preserving, safety of AI, and then there are right now we call them principles, but basically other considerations around accountability, transparency, and fairness. So what we're trying to do really is that you go from the very high level value-based AI should be fair or just or responsible and bring it down to much lower level that designers, developers, evaluators, procurer of AI system know what type of question they need to ask to assess for themselves the type of risk that they have the appetite to manage and have. So think about AI risk management framework as a resource center that provides the right lexicon and interoperable lexicon for discussions of risk across all life cycle of the AI development and use, but also vertically across all the layers of our organizations, from developer all the way to the CISO, on the discussions about risk, what those are, how to recognize them, how to measure them, and enough guidance to do a cost-benefit analysis. And as it was discussed in our workshop, the first question there is the risk of not using AI, right? So we are putting a lot of emphasis on understanding the AI risk, but I want to go back and emphasize that AI is a very powerful tool that should be used. So one of the first discussions and questions to consider is, what's the risk of not using AI? What we are losing by not doing that? So with that, I'm going to stop share, and I'm going to put some links on the chat about risk management framework. I will quickly just say about what's next. I told you about the concept paper that's going to go out, and I told you about the sort of a timeline that we want a completed version 1.0 done by January 2023. In between, there are going to be at least a couple of other iterations of papers for public comments and workshops to hear from the community. And we love to hear from you. We love to get engaged. And I'm going to put some, again, links in the chat, and including my email address, and happy to connect and answer any questions.
Thanks, Ellen. Let's take this framework and what it's hoping to do and make it a little more tangible, Michael, with thinking about the development of some of the solutions that IntelliSite has started developing and using on campuses now and in other commercial spaces, like the thermal scan. Talk a little bit about what how you would use a framework like this to help guide your work to ensure that, you know, some of the ethical considerations, the context of the data, the bias that can be manifest if you're not taking into account the context of data and things of this nature. And it looks like you're pulling up one of the videos, which is really cool.
Yeah. So what I'll do is I'll talk through that along with when you know, we're talking about how do you remove bias, right? So as an example, I know everyone's shocked, but not everyone looks like each one of us. All of us have our certain individual face shapes or geometric patterns, color of hair, skin, eyes, and everything else. And that makes it a wonderful, diverse world. Well, if we only train models to detect people of a certain shape, size, and otherwise, then that can be a challenge. If we want to identify a vehicle, and I'll show you some interesting things in a second, but we only look at pictures or videos of only one type of car that's a specific color of a specific year, we're going to have a lot of challenge. So the way that and we talked, you know, Sherry mentioned this earlier, the way that you remove bias is you make sure that you have the absolute most widest and most rich data set as possible, right? And that's the same thing for any one of our organizations. The more diverse people types and backgrounds and perspectives you have, the general better outcome that you have across the board. And I'm very excited about what our organization does across the board with that of people of many different types and countries. But that's so important when it comes to providing a real AI outcome. So if we have bias in our models, then we're not able to detect things that we should. If we have only a very small data set, then we are not going to present the right information, and it's going to be a flawed data. And then as things continue to change, right, as things continue to move forward, having a machine learning part of that element that is not only leveraging a highly trained model, but is using new data to vet that model out to make sure that we don't have improper information, stale information. And as was mentioned earlier, we don't have models that become brittle and fail as part of all of that. And each one of those things is analogous, whether we're talking about computer vision or we're talking about data-focused AI that's looking for specific trends and gets into prediction and those types of things. But what I wanted to share with you at first is oftentimes people say AI, and they've never really seen it before. So I think that happens for a lot of us is you can see potentially you work in data science or you work in maybe another industry and you're able to run certain, Pi scripts and things like that to develop certain things, whether that's a Jupyter notebook or otherwise. But what does that really, connect? How does that work in the real world? So what you see here is a video where we're using several different types of artificial intelligence. One of those is optical AI model, and that's doing a person detection and then facial detection. So I'm finding a person, and then I'm finding a face, and then I'm focusing in on that area. The second model that it's running in parallel, and this is a composite video of those, is a thermal model. So we're using a passive infrared sensor, so a thermal camera, that's receiving IR data. And based on that, I'm getting specific colors in the spectrum. If you notice here, this is a picture of me, both optical with a thermal overlay, and you see a kind of a cool green view there. I keep telling my wife and kids that that's a cool green. They're like, no, Dad, that's just you. And maybe I'll be cool someday. But the end of that is that if you notice here in this picture, you have a temperature assessment from that. What it's doing is it's grabbing all the composite heat information. And this is a black and white monochrome here because I'm going to talk to you about what confidence is in an engine. But when you get your temperature taken, typically by that little handy dandy thermal gun where you walk into, whether that's a hospital or a place, that's basically contacting one point. Well, the problem with that is, your temperature is not uniform. And I'll show you that in a couple of specific areas. So when you use AI and you bring together optical, so I'm only focusing on a specific facial region, I'm looking at the typically the most accurate point, which is the tear duct as part of that. but I'm able to pull every single heat point off of that, that specific face. What you end up with is the ability to detect and model that out from a confidence level. And what you can see is I have specific levels of confidence that that is the actual average temperature or uniform temperature across that face. Because what you may have happen, and all of us do this, we walk outside, and if you have darker hair and you're standing in the sun, all of a sudden your hair may become a little warm, or you have your glasses on your head, or something like that. Well, what can happen in a normalized environment is without something like this, without leveraging AI to take all of this information in and present information, your temperature may be taken from an outlier spot, which does not provide you or the organization the best value. So what we're able to do by combining optical AI, detection, tracking, facial detection, not recognition, but detection, just like your camera finds the face and focuses in on it, but then also using the thermal and then using data AI to build a confidence composite score. So when you see certain solutions in the market, all they do is they find the hottest point in that specific frame. So if I'm carrying a coffee cup, that goes off as, oh, there's a high temperature here. Or there's other ones that may produce a high temperature, but it actually doesn't reflect it back to a single individual. So when you do bring together artificial intelligence that's detecting and tracking single individuals, doing a temperature assessment from a very specific area on that specific individual in a unique process, looking at the entire temperature overview and developing a confidence score of that, that's how you can create a real solution that is accurate, that is scalable, and allows people to continue and walk and move as part of that. So this is an example of me wearing a mask and doing that same thing, right? So imagine there's multiple people that are walking through a given area, and we're wanting to make sure that we're pulling the best right temperature. And if I have sunglasses and a mask on and all of these other things, you want to make sure that you strip that out as an outlier. So when someone talks to you about artificial intelligence, it's key of the type of model. So in this case, it's a convolutional neural network model that is doing true object detection and tracking. It's inferencing at sub 10 milliseconds, and it's combining and coalescing and validating across multiple AI models, east-west, all communicating, that produces this outcome. And that's why when we talk about scaling from something from one user, and we go to being able to even do that at an intersection, where I'm now looking at vehicles and building composites and looking for information, or if I'm even doing that from a safety lens in parking lots, where I'm looking for vehicles, I'm tracking information. All of this is extremely important, because if I want to build a life safety outcome, that if I can want to detect if there's a vehicle and a person on the same trajectory, if individuals are jaywalking, or if there's a car that's parked in that crosswalk zone, and even students entering a building to have their temperatures assessed, it must be a highly scalable, highly accurate, vetted, valuable solution that was all the models were trained the right way. The data is immutable, as in I know exactly where it came from. It wasn't modified along the way. I can store that in distributed ledgers and those types of things if I choose. This has to be done in a way that is able to be deployed, managed, and updated and vetted along the way. So, Sherry, I'll pass it back to you, but I did want to just share those things so we had a real view. What is AI? How can we train it to remove bias? Do we have all of the right data? Are we deploying this in such a way that we're actually getting up-to-date information? And then most importantly, at the end of that, if all of those things are occurring, I have to have a way to visualize this information. So all of this great data has to be able to be built to where this can be used and leveraged. So city planners, managers, public safety, citizens, so you can build a constituency, all of that community engagement can come together so we can look at all of these types of things that are happening, gain insight from them, pattern that off of models, and really drive the best optimal result for each one of these types of AI projects.
Thanks, Michael. We have a couple of questions. I'm going to start with one that came in for Aham. What kind of human in the loop interventions will deliver accountability to AI systems? Was this a topic?
Yeah.
So
let me answer that at multiple levels. So I'll start by saying that everything that I talked, I keep emphasize. I mentioned the word trust and trustworthiness, but everything I said was mostly focused on trustworthiness, right? On the characteristics, on the attributes, on the properties a model, a data, or system should show to be trustworthy. What they didn't say, and I want to emphasize now, is that that is different. You can build systems that are trustworthy, and that has to be done. But that doesn't mean you get human confidence in them all of a sudden, just because you can show it's trustworthy, right? So building trust, building human confidence is a effort, that needs to have its own focus. That's one thing I want to mention and say that that work is going to require a lot of participation by cognitive scientists, by psychologists, by people that understand technology, but also people that understand the impact of use of the technology, and the people that study the human and human interactions with the systems. Then in terms of the accountability, the reason that we divided them into technical and social technical was based on this criteria that for the technical characteristics, we can have more or less automated evaluations. Algorithms can be run to produce some performance numbers, and those can be easily understood. The social technical requirements or criteria are the one that interpreting the assessment or examination or exploration of the system would require humans' understanding. So you can measure some sort of, well, if we define bias as demographic parity, that, for the examples of the face recognition that we sort of heard about, or if we define bias as demographic parity, how much accuracy is going to change across different demographics, different age groups, different gender, different races. So that algorithm can give you some numbers. Then some human should come and look at them to try to understand, does that mean bias or not? And things can get even more complicated when we start talking about explainability and interpretability, right? If we expect as a mechanism to explain and interpret the result of the systems, then the questions of explainability for who, by whom, at what level, all comes up, right? Example of that is that, for example, if you're using an AI system to look at a MRI of the brain scan and says if it's a tumor there or not, the level of resolution specificity that you want for the explanation to a technician, to a patient, to a physician, are going to be all at different levels, right? And so there are a lot of level of human involvement in building, in testing, and in understanding the result of the testing of the AI system. But I add one other thing, that I suspect when you're asking about human interaction in accountability might be also done by, at the end of the day, if anything goes wrong, who is accountable, who to blame, right? Is it the algorithm to be blamed? Is it the human that takes the responsibility? And I will tell you that for the sake of the AI risk management framework, that's not the purpose. That's not what we're going to do. Again, we are a non-regulatory agency. Our job is to provide the right information, the right resource center in terms of, again, taxonomy, terminology, lexicon, but also guidance and standards for what to measure, how to measure, how to communicate the result of the measurements for different audience. And that audience can be the designer of the system that wanted to design systems that are trustworthy and non-biased and fair, or developers, or the GAOs of the world that are doing the accountability and be able to figure out what sort of accountability framework needed. I mentioned GAO, they came out with a AI accountability framework, I think they call it, in summer, I want to say early summer, that you may also want to look at.
So if I can give an applied science version of that. So effectively, when we're leveraging AI to make specific calls or scoring, there's always supervised reinforcement that's happening as part of that. So as events are occurring, there's people they're looking at raw video, matching that up with an AI outcome, and then determining that if that was the most appropriate response for that. And then you used a specific reinforcement loop to make those adjustments. That's why it's so important to do not only training, real training, and then you do also synthetic retraining. And then as part of that, you run that against real data and you run that against synthetic data as part of that too, to make sure that everything is aligned. And just to call out one thing very specifically, facial detection, right, is extremely different than facial recognition. Recognition means I'm matching that to an identity that I know, right? I have identified information. Facial detection simply is I'm locating a face, right? But here's the important part about even removing bias for that is obviously faces are very different color, shape, sizes. You even have distance differentials in the eyes, ears, and things like that. So it's so important that the data set that you're using is very diverse in nature. And you can even use synthetic blends for that. So where you're using things called a triplicate or a triplet, when you're doing that and you have two of the same picture and you slightly synthetically modify that, or you have an image that's different that way, it really helps in that process to ensure that if you don't even have the best, most diverse data set, to be able to do that synthetically so that you ensure that there's nobody that's being left out as a part of that. And then you test, reinforcement train, and validate as part of that. And that's what we do with our models. That's how we can be highly accurate and ensure that we don't leave out different people types or object types.
You see, so what you're describing is really sort of like best practice for anyone developing these models. And you can imagine, of course, there's variability across people who develop these things, right? And perhaps different motives as well. Do you ever foresee, like in the cyber world, there's lots of frameworks, and you have the CMMC process now that exists. And that gets into certification and validating specifically. Do you either one of you, in the few minutes that we have, do you ever see something like that being created for AI, where you actually have some sort of certification?
I'll get on that. So CMMC, if I am correct, if I'm not mistaken, let me just go back and then come back to CMMC. So you ask for some sort of certification, right? So certification, you do certification or conformance testing according to some specification, right? So somebody has written some specification, and either through self-attestation or second or third party attestation, you get certified to those specifications. We don't have those specification for AI yet. As part of the development of the AI risk management framework, we're aiming to develop that type of specification, that if you want to test for or certify for, let's just for the sake of argument say that your system is not biased, then you know that what are the things that needs to be accounted for from data all the way to the result of the algorithm, and sort of working with the whole community and involving the standard community to develop those specification. Then testing parties can do those certifications. So in CMMC instance, the specification that CMMC does the certification to, it's some of the guidance that Nist has developed. So, so the work that we're doing is bringing those type of specifications for doing testing. And, Michael talked about recognitions and detections and identifications, and these are, in the biometrics world, again, there are standards that talk about verifications. I'm using the standard word for all of them, which is the verification of the claim of identity versus identification, which is what Michael talked about as recognition. That's finding one person among the list of that. You show it to the algorithm and say, find this person from this list for me. So I just mentioned that as again, the importance of having terminology and taxonomy, particularly the same use of the same vocabulary, because if we want to bring the whole community of the researchers that are doing, sort of a bleeding edge research in the field of AI, to the technology developers that are building the technology, to the standard community that are writing the standards, to the certification entities of the world that are writing the certification, we want to make sure that we're all talking about the same language, and also using interoperable metrics. And so when it comes to having specification is one thing. When you want to do the testing, there's also important things to consider there, that the testing is interoperable, right? Each of us can go and get the testing and do it in different ways. We see it in the academic literature a lot, that the results, the same algorithm tested in different evaluation benchmarks wins one benchmark and does okay or less than okay in another one. Why? Because, for example, test data can be different, or the metric used can be different, or the way the results are presented could be different. So again, emphasis on standardized way for both understanding, communicating, and evaluating different aspects of AI systems. Pause here.
Well, unfortunately, that's all the time we have today. We could spend easily another couple of hours talking about this. Thank you, Elham and Michael, for your time today. And for those of you in the audience, thank you for coming, and enjoy the rest of the workshop today. Thank you.